All right, I like blue. Remember, chromosomes are inherited in pairs. You get a chromosome from your mother, chromosome from your father. What we're calling a locus is a site on the chromosome, like right here. Like maybe that's the locus that determines your blood type. And let's say we're talking about ABO blood types in specific. We're talking about that big H, little h, or whatever. If both of these are coded for that, you're homozygous, big H being dominant. You're just a type O. If you had that, you're still a type O, but now you're a heterozygous type O. They're not the same, they're different. And the term antithetical is opposite allele. That would be like the difference between here and here. This little h is antithetical to this one. That term's not on your test, I don't like that term. So, homozygous versus heterozygous, this is heterozygous. Two alleles for a given trait are different.
What's an allele in this context? How would we label it?
An allele is an alternate form of a gene at a particular site. So here versus here. These are your alleles. An allele is part of your chromosome.
Are there 4 alleles up there?
Yes. 2 chromosomes, 4 alleles.
Cool.
Now, when we're talking about ABO type, the correct way to do that when we're talking about type O would be to write an H. Like this. For simplified versions, a lot of times in your book, you're going to see this. Think of that the same. If you have the big H, you're type O. But it's also possible to have that. A and B are dominant over the H. So regardless, and let's change this back to the correct terminology, which would be this. That person is type A. That is what you're going to see when you blood type them. Heterozygous A. That's also possible. That is homozygous. Both of them are going to type A. The Punnett squares is how we figure out possible blood types. Have you already done Punnett squares in biology?
Oh yeah. My God.
So let's say your mother is type AA. Simple enough. Your father is type BB. The only possible blood type for the offspring is type AB. Because when you combine them, that's the only possible blood type. Yes?
So if the mother is AA, does that mean she's homozygous?
She is homozygous for the A.
Gotcha.
But let's change this up. Let's say mother's not AA.
She's AO.
Let's say she's AO.
Ooh.
Or AH, whatever your preference. Now that changes it up.
BO. Boo.
You have 2 potential blood types. They're either going to be AB or that, which will express as type B.
Mm-hmm.
You still cannot get a type A baby out of these 2 people. When we've talked about paternity testing, somebody mentioned it in lab about paternity testing with blood types. You cannot determine paternity, but you can determine possibilities.
Okay.
So, if mother knows that she's type O, and she says that daddy is type B, or we know daddy's type B, whatever. Let's give him the best possibility, we'll say he's BO. Baby comes out type A.
He's not, yeah,
One thing I know for sure,
is that he's not the father.
that is not the father. Because type A is not possible.
Better call Mom.
Because the only possible blood types you get
Is boo and ooh.
is type B and type O.
Ooh and ooh.
If baby is type A, that is not the father.
Right.
Now this, by knowing these blood types, I can't say he, like, is or is not the father. Well, I can say he is not the father. I can't say who the father is.
Right.
And that's just like if the baby comes out type B, he still might not be the father,
Right.
Yeah.
but whoever is type B.
Right.
You know, so that's kind of how that works. What would you get if both parents are type O?
You're gonna have a type O baby, right?
You have a 100% chance that your child's going to be type O.
It's gonna be
There's no other possibility.
Right.
My dad's O and my mama's A.
So that is how you can have a parent and say both of your parents are type A and you're type O. That means both of your parents were AO, not AA. That's right. And that's how this is possible. And that's Punnett squares, and that's how that works. And that's how you can tell potential blood types of your children.
So if I'm AB, one of my parents had to be A and the other one had to be B.
Yep. Yeah, no doubt about it. Don't let
Do a sister DNA and see if you match any of your folks, cause that's how kind of my grandpa was. Ain't lying, my grandma was an
And let's go the other extreme. If both parents are type AB, what are our potential offspring?
AB. Alright. No, AB or B.
A.
A, B, and then AB and BB.
So it'd be AB, A, or B.
You got like 3 different chances.
50% chance they're gonna be AB. They could also be a B or an A. 25% chance each.
Yep.
My mom's though, I don't know what my dad's blood type is, but I'm also O, so.
But O's a little different. If you're O, if both parents are O, that kid's gotta be O. If that kid is anything but O,
Something's wrong.
somebody been slipping. Somebody been slipping.
When I was
Slip right on top of it.
we did one like the term, we determined, we did like one italicized 5,
Mhm.
first one or whatever. So when like, we never put O, they were like heterozygous, we did like double I.
Yeah.
Me and homozygous, just double I.
Like I said, actually, the correct way to write someone who's O would be that. I don't like that because it just adds confusion.
You said it.
I like to use O for type O, even though technically they're O because they have the H antigen. Why they don't rename this to the O antigen? I have no idea. Wouldn't that make it so much simpler?
Yeah.
You have the A antigen, the B antigen, and the O antigen.
Hey, you're type H. I'm like, what?
What's that mean?
Yeah, exactly. That's why they're type H, you just blew their mind.
Well, because everything always says ABO blood type and not ABH.
Exactly.
ABH.
And that's why when I write it as O. I write AO, not AH or BH. I write O.
Hang on.
Oh.
You just need to know that type O person is type O because they have the H antigen and that's it. What would be your type if you had no H antigens at all?
That's gonna be that Bombay, right?
You don't have blood type. That's what you call it, is Bombay.
Bomb.
They will actually type out as a O on the front. Basically, all their tubes are negative. That's how it works out.
So how does a blood transfusion work for them?
They can only be given blood by another person with Bombay.
And that's really, really rare, right? So they use the
Like I said, there's one village in the Bombay region of India that has, is it India? Bombay's in India. isn't it?
I think so, yeah.
There's one family in that region that has that blood type.
So
So if you need blood, you better go talk to your cousin.
So wait, what if all your family's dead at this point?
Well,
you're screwed.
Then you donate your own blood.
I'm coming, Ma.
Well, no, she has a point. You donate your own blood ahead of
So
time.
that's not even listed on potential types because it is so rare, there's like 10 people on Earth.
And they're gonna be gone soon too, right?
It's India, they have lots of kids over
Even if India stopped
So,
reproducing
when
there. Okay, so type B,
Whenever
so we've already
mixing the
mentioned.
blood.
What is the phenotype of type B? What will it type out as?
Like if somebody had Bombay.
It will type out as B, they have the B antigen. But what are the possible genotypes?
There would be a possibility
BB and BO.
they'd have the kid and the kid would only have O. But I don't know if it's like.
So what about the phenotype of type AB?
Bombay's
What do we
dominant, and if it's
see
just
when
gonna
we type
type
it?
A.
AB.
They type
Could they
as
be a
AB.
carrier of the other?
What are the possible genotypes of AB?
AB, A, and B.
That's it, AB.
And
O is the same way. Phenotype says an O, which is an absence of the A or the B antigen. And the possible genotypes for O is OO. That's it.
Ooh.
Well, that's
And we've
confusing.
already done the next part a little bit.
What about the H?
And the last line, blood grouping for paternity can exclude or disprove certain people, but it cannot prove paternity. You'll know through your blood type if you ain't the daddy.
Do
Right.
they still use it though? Because I mean, no one wants to know
That's
if
one
they're-
of the tests performed in paternity testing. Cause it's quick, it's easy, and they could possibly rule it out that right there, and they don't have to do DNA testing.
That would be
Save
the
that
first
They'll
step.
blood type it first, then if it's still a compatible possibility, then they go further for the paternity testing.
it's like with my mom and dad. My sister's type O and I'm type B. And so my mom's type B. And they're like, oh, that ain't mine. It's a white man's child. It's like, okay. Let's discover
Well,
this
my
out.
mother, and I learned after taking this program that my father is BO and my mother is AO. Cause he's B, she's A, I'm O. The only possibility is AO and BO. So I now know their genotypes without ever testing. Yeah, there.
Okay, so phenotype for type B again.
Phenotyping type B is just positive for the B antigen. They will type out as a B. They look like a B on testing. That's the, phenotype is what we can physically see.
The genotype.
The genotype is a possibility of BB or BO. Remember, genotype, we're talking about genetic makeup, not visible or physical
Not
makeup.
traits.
How do you find out if they're, phenotype or, how do you find out their, genetic makeup, if they're A or AO? How do you do that in the lab?
You don't do that in the lab.
So you just don't have like a clue?
You'd have to send it out for, they usually do genetic analysis for that if they just wanted to know. But it's not something we're gonna do in blood bank, because we don't care if they're AO or AA, because they're type A.
Okay.
Makes no difference. So Landsteiner's law, again, if you lack the gene, you will have the corresponding antibody. If you lack that gene for the B antigen, you will have anti-B. These antibodies were once said to be naturally occurring. I've said that many times. They just, if you're type A, you have anti-B, it's just natural. Meaning that no specific event stimulated their production. This has changed somewhat thanks to what they call the chicken experiment. What they did, chickens have blood types, believe it or not.
Yep.
And they'll have, they don't have type A or B, but let's say if they have type A, they have anti-B, you know, very similar occurrence.
Okay.
They raise chickens in a completely sterile environment. No bacteria. All of their food was irradiated. Their water was irradiated. They were raised completely sterile. They never produced the corresponding antibody.
Huh.
So as a result, now they start to think that maybe exposure to plants, bacteria, animals, something in our environment must be stimulating the production of these antibodies. They don't know what it is, and they don't even know if it's true for humans as it is for chickens, because we can't take a child and raise them in a sterile environment as an experiment.
You could, but you'll go to jail.
Yeah, that's heavily frowned upon to do experiments of that nature on children. So we're not sure, but we do suspect that these antibodies are non-red cell stimulated. Means something in the outside environment is what stimulates these antibodies. That is just a theory at this point, and it will probably never be proven, because that's not something we can test, not ethically. Important line on the next one. Type A's have anti-B, we know this. Type B's have anti-A. Type ABs have, it's not anti-S, they have no antibodies. Type O's have anti-A and anti-B, and also a third, called anti-A, B. It is not a mixture of these two antibodies. It is a third antibody that will react with either. Well, the significance of this is that A comma B antibody has a tendency to be IgG, which means it can cross the placenta. So what you will see is if you have a type O mother who has a type A baby, that A comma B will cross the placenta and attack the blood of the baby because it has the A antigen. Fairly common to see in the lab. You need to be aware of that because that is, I used to cringe every time I was doing a cord blood on a newborn. And as soon as I looked at the history, and I see that mama's type A, or type O rather, I'm sorry. I see she's type O, I'm cringing. Because if you get anything on that baby other than type O, chances are you're going to have some sort of reaction because that A comma B crossed the placenta. It's not a big deal. Tends to destroy some of the baby's red cells, which means the bilirubin goes up. They got to put them under the lights, all that jazz. It creates a few days of, not necessarily a problem, but a severe inconvenience. Lengthens hospital stay, that sort of thing. It always resolves just fine. I've never seen one go bad. But you just know that you're going to have a baby with an elevated bilirubin if you're in chemistry tomorrow.
So usually with all A's, all A's?
That's the most common. O mothers. O mothers with A babies.
O mothers.
With A babies.
That is, I mean, it's possible with O mothers and B babies, but the most common you'll see, in my experience, is an O mama with an A baby.
Question.
Yes.
The antibodies for an O patient. The O patient will always have these 3 antibodies.
Yes. I'm O positive. If you test me right now, I have anti-A, anti-B, and anti-A comma B. And like I said, that's one that just, it tends to be IgG and it will react with both. The exceptions, they proved this to me at CHI because it blew my mind. I was doing a blood type on a patient, front type, worked out fine, back type, all the tubes are negative. Like, this can't be right, they're not type AB, I think they were type O, which meant every tube was negative. So I did it again, it's all negative. So I asked the tech that was supervisor, what's going on here? She thought about it, she said, what's the patient's age? I looked and they were 97. She said, there's a problem. People of advanced age, at a certain point, will stop production of antibodies. They're at the end of life, their immune system's starting to wind down, it's done all it can do. They will actually halt antibody production, which means they won't have anti-A, anti-B, they won't have any antibodies in their plasma. So it can mess up your back type.
Your back type.
Just your back type. Your front type's still correct. So it's like, I know what the back type should be, but it ain't there. Same thing, and this is why we don't do back types on babies. They will not even begin antibody production for 3 to 6 months. So there's no point, it's gonna be negative. There's no antibodies there.
You just set the first 3 things then?
Yeah, you set up A, B, and D.
Okay.
Yeah.
Could this be true for someone who's extremely immunocompromised?
Yes. Anything that has wiped out the immune system, that's one of the things that can be affected is your antibody production.
I think that's just like.
Because again, what produces antibodies? B cells. If you ain't got enough B cells, you ain't got no antibodies. Whether that's ABO antibodies or your antibody to chickenpox, whatever. It goes on to say ABO antibodies are IgMs. That's why we don't have to incubate and all that. We just centrifuge, shake it out, it's positive.
You can see it in the figure.
Yes, but a certain percentage of this A comma B will be IgG. And that is capable of crossing the placenta.
You had to have complement to see that.
The one study I read about that said that 70% of A comma B is IgM, but 30% of it is IgG. And that's why it can cross the placenta. And here's just a pictorial representation. They don't show the A comma B on there under group O. Just remember that one is there. So that's just a good slide for representing your blood types, what's there, what antibodies are there, etc. Oh, this is a good one. This one took me a long time to wrap my head around.
Oh Lord, that's lovely.
The secretor gene, indicated by SE. Determines secretor status. Secretors secrete soluble blood group antigens in their body fluids. So if you're a secretor, I can blood type you through spit, through urine, through semen, through breast milk, through whatever. Those antibodies will be present in other parts of your body. A large number of people are secretors, not all, so it's not foolproof. You can see under the alleles, if you have a capital S, you're a secretor, because that is the dominant. You have to be little se to be a non-secretor. Type O secretors will demonstrate the H antigen. That's what they got. It's the only antigen they got. It's the H antigen. Type B secretors demonstrate the B and the H. Non-secretors have none of the above in their secretions. What would a type AB secretor demonstrate in their secretions?
Everything.
A, B, and H.
A, B, and H. It would be the least amount of H, but it would be there. There is an antibody that we're going to discuss in a future chapter called the Lewis antibody that is 100% based on secretor status. That's part of why this is important. This is also how, like say crime lab, when they do like a rape kit or whatever, that's how a lot of times they know the blood type of the perpetrator. And that's how they're doing it, because they found out when they tested it, they were a secretor.
How'd they do that?
Oh, so that's.
How'd they do that? They took some semen or something and,
Part of a rape workup is a vaginal swab.
Yep.
If there's anything on the panties or whatever, of course, they take all that too.
Right.
That's part of that workup. And that's one of the first things they look for.
Secretor or non-secretor?
is it,
Watch
is it-
forensic
is it
files.
some kind of genetic test? Look
They
at-
will, this is gonna get gross. They will take the dried semen and they will rehydrate it in fluids. Then they will test that fluid for these antigens.
Because the antigens have left, the individual semen, pieces and started floating around in the rest of the solution.
Or get a urine that somebody peed in the roof and they got semen.
Now they have to differentiate also because they are gonna have to draw blood on the victim. Because they have to know her blood type, because if she's the secretor, those are gonna be in her vaginal secretions. So they have to be able to differentiate. So transfusion of non-specific group blood. If you're gonna give non-type specific, give type O. Because you can give type O to anyone. It's the universal donor. We will give it in emergency situations, but we do prefer to give type specific. 2 reasons. Number 1, they've just proven that type specific just does a little bit better. And number 2, we don't want to wipe out our supply of type O's. If we know they're type A, there's no reason to give them an O. And like even type O, packed red blood cells, we've talked about how it's separated out. Even after it's separated, there's a very small amount of plasma there, which means it does have some antibodies there. And that's why the type specific just does a little bit better than type O. You have better red cell survival. Type AB, universal recipients, you don't have antibodies, you pour whatever type of blood in them you want. There is a preferred list that we keep up. AB, we want to give type specific first, so if they're AB, we want to give them AB. Our next choice is type A, then type B, and then type O. Why? Because that's the order of frequency that we have the most blood in. We're going to switch to a different type. We got more type A's than we do anything else just about. FFP should be ABO compatible. There's antibodies in that plasma, so it has to be compatible. Cryo and platelet concentrates. Best to give ABO compatible, and I always try to, but you can alternate ABO compatible with non-compatible if the cumulative volume is not large. It's really not going to matter that much. While there's plasma there, it's such small volumes that it's not going to make that big a difference. And there is a section in your book for ABO discrepancies. We're going to talk about that some throughout. You know, we're going to give you some blood types that won't work occasionally. So just kind of, know what you should get on a blood type, so that you at least know that there is a discrepancy. So you can go, whoa, wait a minute. Because the first thing you do in the lab when something weird going on, you ask somebody with more experience.
Raise your hand.
I don't think the book's gonna tell you that. That's the first thing I'm gonna do. If somebody's been there 20 years and I've been there 2 weeks and something weird's going on, I say, hey, can you come look at this?
Right.
Don't get me wrong, there's some jerks in the lab, and almost no one's that big a jerk. They'll say, yeah, give me a minute, and they'll come help me out. End of slideshow.